Hello, guys. We taught our classmates in the previous class on Colab. Colab is Google Cloud Service. Download the K-line data of the blockchain cryptocurrency. This is very simple. After getting the data, you know how to apply it. We're going to backtest the strategy today. With sufficient data and cloud platforms, we can quickly learn Python. In the context of quantitative trading, because many students are use Excel in their office or school, let's practice backtesting in Excel first. Then copy these rules to Python. You can learn how backtesting works. Another key point is that Python works like Excel. You can think of Python as Excel plus. Try to learn Python as learning Excel, so take it easy as possible. Let's use the previous K-line data first. We used the CCXT module in the previous class because it can connect to different exchanges. Because some exchanges may run faster. Some exchanges can't be connected. Binance can't be connected. Because Colab servers are in the US, it can connect to the international Binance. I will use another exchange instead. Since CCTX can connect to different exchanges, today, I use the K-line data of BingX exchange. I downloaded about 500 rows of BTC daily clients. The latest is April 4th, 2024. That's today's client data. The last price is 66,807. This is the latest data and the closing price. Let's draw this picture first, then save this data into Excel. All our classes today are in the environment of Google Service, so you can learn by using browser. No need to install Python or use Excel sheet in your computer. Today we use Google services only. We save Bitcoin K-line data to the driver on Google. Open Excel on Google Sheet. This is the closing prices for Bitcoin. The last price is 66,807. So let's take a look at the last row. So today we are mainly in Excel. I think everyone who watches my channel use Excel well. Let's use Google Sheet to run vector backtesting step by step. The vector backtesting is a multiplication approach to calculate the final rate of return. First, let's calculate the daily rate of return. We will use the compound rate of return. Calculate the daily price change first. What is the rate of return on this day? It's today's closing price divided by yesterday's closing price. Then subtract 1. That's daily price change rate. Next, we need to calculate the compound rate of return. The compound rate of return is the continuous product of daily returns. Yield on the first day equals 1 plus today's rate of return. But the next day, that is, on the third day, we're going to multiply by yesterday's yield. So it's yesterday's rate of return, multiplied by the day's yield. So it's a compound rate of return. The yield of Bitcoin in the past 500 days is quite huge. So its compound rate of return is 406.69. Bitcoin has been a little more volatile recently. This is a vector algorithm of compound rate of return. Next, we need to develop a strategy. Short-term moving average and long-term moving average. The golden cross and death cross. Let's first calculate the short-term average SMA. I set the short-term moving average to 5-day. It starts with the 6th day, the average of the 5-day closing price. I also calculate a long-term moving average LMA. The short-term moving average is 5 days. I use 10 days as the long-term moving average. Let's calculate a shorter average. Long-run average is the same. I set LMA as the average of the 10-day closing price. Then we can have a strategy. We can have signal column by comparing SMA with LMA. If the short-term average is larger than the long-term average, it's long. I set signal as 1. -1 if the opposite is true. We build a dual moving average strategy here. Let's check the signal. December 7th, 2022 is a negative day. The short-term moving average is 17,170. The long-term average is 17,215. The short-term average is lower than the long-term average. How to get the signal? How to use the signal in compound rate of return? We need to multiply by today's holding side. I add a column strategy return. Okay, the same algorithm. We multiply the long-short set. Start from 11th day, because the first signal was only received the day before. So if it's the second trading day, yesterday, it was a long position. Copy the equation from column G. Multiply by its side. since it was long and the signal was 1 yesterday. It is the G11 field. So we calculate yesterday's rate of return. The first trading day is December 1st, 2022. The rate of return on the first day is the next day on December 2nd. What about the third date? Just multiply by yesterday's yield. So let's multiply by yesterday's yield, H12 times today's yield. So this is a compound rate of return algorithm. Same, and I'm going to calculate the yield to the end, because the last day is April 4th, 2024. Let's take a look at this strategy. Is it positive or negative? It doesn't feel good. But it doesn't matter. We learn algorithms. So, we can see the last day here. What about April 4th? Without the strategy, the yield is 406.69. If you use this strategy, the yield of dual moving average strategy is 113.23. The gap is quite large. Let's compare the yield by plot a graphic. Okay, insert a diagram in Google Sheet. So we can compare the two strategies. One is hold strategy. The other is a poor strategy. Because this is backtesting lesson and I use random parameters, and we already know it's bull market now. The result is for your reference only. So this is a vector algorithm. We use the daily rate of return, multiplied by the position direction. The original hold strategy, it's all long every day, never sell. The dual moving average shows how to use vector in Excel to run backtesting. That's the practice in Excel. Our goal is migrate this strategy to Python. First, let's calculate the moving average. 5-day moving average and 10-day moving average. SMA equals price. Dot rolling. The first one is the 5-day average, then the mean. Copy the short-term moving average. Just change the window days. It is the same as what was just run in Excel. There's a short-term moving average and a long-term moving average. In addition, we need to calculate the signal. It's faster to apply lambda. Okay, long-short position is the same as what we did in Excel. The signal has been calculated. However, it should be noted that, because we can choose weak row as the first row of our strategy, so we can't use -1 for the first 10 rows in Python, because this is actually a null value. I'll change it here. Okay, we finally have the correct signals. It's the same as we just did in Excel. Next, we have to calculate the daily rate of return. Let's do the math first. How to calculate the daily rate of return? I'll show return equals price % change. Okay, we have the result now. What's the yield per day? This is what we just calculated. It must started from the second trading day. Next, we need to calculate the rate of return of the strategy. Let's first calculate the compound rate of return. Then Rhino strategy is hold strategy. This is the compound rate of return without strategy. That's cumulative. The last one is for 0.088. The return increased by 4 times. 500 days has quadrupled. And let's use apply strategy now. Next, calculate the rate of return for another strategy. Let's calculate the rate of return of the moving average strategy. The dual moving average needs a signal. Copy the yield function from the hold strategy and multiply the long-short sign. Our long-short sign is shift the first. Multiply it by today's yield. So this is a yield. Added a change in position. The direction of the strategy is added here. After that, we can see the final result. These records, it's almost the same as what we just calculated in Excel. Because there are some decimal point differences. The rate of return of hold strategy is 4.088. Through dual moving average strategy, it is 1.12. There are some floating point differences. Finally, we migrate vector backtesting from Excel to Python. That's easy, right? The focus of this lesson is that you can transfer many operations from Excel to Python. Python offers more flexibility, and backtesting is not difficult. You can take quantitative trading as a scenario for learning Python. So that's today's sharing. Remember to subscribe. See you next time. Bye.